Hello. So today we're going to look at how to write an equation of a circle. All right. This, along with a few other things that we will do on Thursday and Friday, will finish up our circle unit. The equation of a circle has a standard form, and it looks like this. You're going to have x minus some number, that quantity squared, plus y minus some number, that quantity squared, equals r squared. Now these numbers, h and k, represent the center of your circle. All right. R is your radius. So when you look at the equation, notice the standard form has a minus. So when you're trying to identify what h and k are, you want to think opposite. Excuse me. All right, think opposite to identify h and k. So if you see a -2, it's really a +2. If you see a +4, it's really a -4. All right, r is your radius, but the number that you're going to see is going to be some number squared. So in order to identify the radius, you're going to take the square root of whatever that value is. All right, so let's just take a look. First, we're going to write the equation. So it says, given the center and the radius, or the diameter, so read carefully, we want to write the equation of a circle, and that should say in standard form, not if. All right, so if I'm given the center as 4, 2, that's my h and my k, and I'm told that the radius is 25, so this is r. So I'm going to just fill in. So I'm going to have x minus the h value, 4, square it, plus, and then I'll do y minus the k value, which is 2, square it. And then this is going to be 25 squared. So I'm going to write it like that for now, but you can't leave the r value squared written that way. You actually have to do the math. But I just want to point out, so when I look at this, just to reverse it, if I see -4, my h really should have been a +4. If I see a -2, my k should have been a +2. All right. The way you're going to leave it is going to be the quantity x minus 4 squared plus the quantity y minus 2 squared equals, and then you're going to actually square that. So this is what you will give me. Don't ever leave me the r squared like that without multiplying it out. All right. 1b, the center is 0, 0. So if we were to write it, I'll start over here. We would do x minus 0, the quantity squared, plus, and then y minus the second 0 squared equals 49 squared, because 49 is the radius. The other thing you don't want to do is when you have zeros, don't leave it like that. All right, we're just going to write this as, this would just be x squared plus y squared equals, and then with the help of our calculator, we would have 2,401. Okay, so again, when you are subtracting zeros, that's one of the coordinates of the center's ordered pair. Don't leave it that way, just reduce it down to just a simple x squared and a simple y squared. All right, C, notice both h and k are negative. So when you go to fill in your formula, if it's going to be x minus and then -3, that's going to become a +3. All right, and then we have plus y minus, and it's a -9, so we'll do +9. Now when you have, notice this is the square root of 5 is our radius, so if I have the square root of 5 squared, remember squaring and square rooting cancel each other out. So your final answer for this is going to be the quantity x plus 3 squared plus the quantity y plus 9 squared equals 5. All right, and then for part D, all right, we're given the center, and this time we're given a diameter. So real quick, let's figure out the radius. And the radius, of course, is half of that. So that's the number that we want to use. All right, so my equation is going to be x minus the 13 squared plus y minus a -1 makes it a +1. That quantity squared equals 36 squared. So all you need to finish doing is to use your calculator to figure out 36 squared. Now, you'll notice for these examples, I did pick numbers that are perfect square, right? 25, 49, we use 36. So you got to be careful because common mistake is to see a number that looks like a perfect square, and so they think that the radius would be 5 or 7 or 6, all right? But take your time and make sure you are substituting whatever the radius is into the equation and then squaring it. All right, let's reverse it. So now we're going to be given the equation, and I want you to tell me what the center and radius are. So when I look at this, remember we're going to think opposite. So the center, I'll use capital C, is going to be +8, +1. The radius is the square root of this number. Because remember, the number being shown represents r squared. So the square root of 9 would be 3. All right, look at part B. So I see a +4, so that means the x-coordinate, or the h, is really a -4. There's nothing being subtracted with the y, so that meant that coordinate is a 0. And then r is going to be the square root of whatever number is here, 36, which would be 6. C, again, think opposite. So it's going to be +11, -3 for my center, +11, -3. And then the radius is the square root of that number. Square root of 10 is not a perfect square. If you can reduce that radical, you would, but we can't, so we're going to leave it just like that. All right, the third example actually gives you a picture. So when you look at the picture, and I know the dotted lines are probably very faded if you printed it out, but it looks like my center is -2, 6. I'm just going to write that up here, -2, 6. The radius, what you want to do is from the center, you can count either left, right, up, or down, all right? But count the squares and that distance. So I'm going to count back. I got 1, 2, 3, 4, 5. So my circle has a radius of 5. Once you identify those two things, then you're doing exactly what we did back on part 1. So your equation, all right, well, let's read the directions. The coordinate of the center we got, the radius we got, and now we need the equation. So we've got x minus a -2 makes it x plus 2, quantity squared, plus, and then we'll have y minus the 6, that quantity squared, equals 5 squared, which is 25. So I'm just going to go ahead and write that. All right. Now, to write equations when you're given something other than the center and the radius, there's going to probably be a little math involved. Not probably, there is. So when we are writing equations of circles, we always need to know the center and the radius. Those are the two things we need to know. So in number 1, we're given the center, okay, so we're good there. But then we're given a point on the circle. So just to give you a visual, all right, you've got the center and a point on the circle. It doesn't really matter where on the circle it is. If I were to connect it, that's my radius. So what I need to figure out is the distance between these 2 points. And if I can figure out the distance between those 2 points, I will know my radius. All right, so to get r, we're going to use the distance formula. One of these points will act as an x1, y1, the other as x2, y2. Doesn't matter which one's which. All right, so we've got the big square root, and then underneath we've got, I'm going to do -1 minus 1. So I'm doing x1 minus x2 squared, which is fine as long as now I do y1 minus y2. All right, if you did 1 minus -1, then you would do 8 minus 6. All right, so keep going. So I've got -2 to square plus another -2 to square. That gives me 4 plus 4, which is the square root of 8. Now, our object here is to write the equation. So I'm not worried if you simplify that. If it asks for the radius, then I would want you to give me that in simplest radical form. But we just need to know what it is so that we can now write our equation. All right, remember, this is the one that's the center. So we've got x minus a -1 makes it a +1, plus, and then y minus the 6, that quantity squared, equals, and then our radius was the square root of 8 squared. And then the squaring and square rooting cancel, so our final equation is the x plus 1 quantity squared, the y minus 6 quantity squared will just equal 8. Now, these are the notes. I know that many of you, if not all of you, could take that and square it and know you would just get 8. So I'm fine if you go from here to here. But these are our notes, so I'm just writing it out so that you can see and remember what we did. All right. Number 2, again, we're given the center and a point on the circle. So same problem as we did before. So we'll very quickly define the radius. We're going to do the distance between these 2 points. Again, decide which ones are your 1s and your 2s. All right, this time I will follow the formula as we always did it. So I'm going to do -1 minus 2, quantity squared plus, but then I have to do the 4 minus a -4. All right, so what I'm really doing is I've got a -3 I need to square, and this here becomes a +8. So we've got 9 plus 64 is the square root of 73. That's my radius. This point here, the 2, -4 was our center. So our equation is going to be x minus 2, the quantity squared, plus y minus a -4 makes it y plus 4, the quantity squared. And then this time I'm just going to show if we square this, it just becomes 73. All right, notice in number 3, again, we're given the center, but then we're given the circumference. So we're going to use the circumference to help us figure out what r is. All right, so just like we did before, so if the circumference is 20 pi, we'll put that on the left, and the circumference equals 2 pi r. And we want to use that formula, not pi times the diameter, because r is what we're looking for. So notice what happens here when I go to divide by the pi's, those are going to cancel each other out. And so all I really need to do is divide by the 2, and I get r to be 10. And then we're ready to write our equation. So I've got x minus a -4 makes it x plus 4, the quantity squared. All right, notice this is 0. All right. Now again, because these are our notes, I'm going to go ahead and write y minus 0, the quantity squared, equals, and then this would be our radius squared. If you want and can do it so that as you are filling in, you can make it look like that, then you are good. Remember, no zeros, don't leave them. And make sure you always square out that radius and give me just a single number. Number 4 is very similar, but this time they give us the area instead of the circumference. So let's use the area formula. So area, which is 81 pi, is going to be pi r squared. Okay, again, we still need r. So notice the pi's will cancel when we try to divide those out. So 81 equals r squared, and then we'll take the square root. So r is 9. All right, so again, here's our center. So I've got the quantity x minus 7, quantity squared plus, and then y minus a negative 2 makes it a plus 2 equals, and then 9 squared is 81. Done. All right, and then our last problem. We're not given the center or the radius. We're not given either. But what we are given are the endpoints of the diameter. So again, just a little visual, not that we don't have to be exact. All right, but the 2 points they're giving us would be out here. So if I find the distance between those 2 points and then cut it in half, that gets me my radius. All right, so we have to do that. But then we also need the center. So if you think about a diameter, the center is always the middle of a diameter. And so what we're going to do is we're going to do midpoint to get the center. And we're going to use distance to get the diameter or the radius. Because I'll give you a little hint, if you find the center first, then you can do the distance from the center to either one of these points to get the radius. All right, or as I said before, you can do the distance using these 2 points, that would be the diameter, and then we'll cut it in half. All right, I'm going to start with the midpoint. So we haven't used that formula yet. The midpoint is, right, now again, let me label, whoops, x1, y1, x2, y2. The midpoint formula says we're going to add x1 plus x2 and divide by 2. So we've got 1 plus 9. We're going to divide that by 2, comma. The y-coordinate is going to be y1 plus y2 divided by 2. So negative 14 plus negative 10 divided by 2. So I've got 10 divided by 2 and negative 24 divided by 2. So my midpoint is going to be 5, comma, negative 12. All right, now when I do the distance formula, if I want to get the radius, which is what I want, I don't want the diameter, I need the radius. I'm going to take this point and one of these. So I think I'll use this one, the 1, negative 14. And these are the 2 that I'm going to find the distance between. Okay, so I've got, I'm going to do 5 minus 1, quantity squared, plus, and then I'm going to do negative 12 minus negative 14, quantity squared. So this double negative is really going to be a positive. So I've got 4 in the first parenthesis that I need to square, and then I'll have a positive 2 in the second parenthesis I need to square. So we'll have 16 plus 4, which is the square root of 20. Now remember, you don't need to break that down. We just needed to know what it was. So now we've got the center. And you know what? I should probably get in a habit for these. Instead of calling this M, I should call this C. So that's our center. And here's our radius. So we're ready to write our equation. We've got x minus a 5, quantity squared, plus, and then y minus a negative 12 makes it plus 12, quantity squared, equals the square root of 20 squared, squaring and square rooting cancel, so that would just be 20. Here's your equation. All right, so again, Instead of calling it M this time, let's just call it C when we're finding the midpoint, because that's what we're finding, the center. And then for distance, just make sure you use the center if you want, and one of the endpoints, or use the two endpoints of the diameter, but then we would have to divide it by 2 at the end. All right. Notice in all the examples, not once did I use decimals for the square root of anything. All right, so you're always going to be working with the radicals. I don't want you to change the square root of 20 into a decimal or anything like that, or anywhere else. Okay, keep things as radicals and work with them that way. All right, you should be ready to practice circles or equations.